Hi everyone. So I wanted to finish up our energy lesson by showing you how to calculate the second Q equation. So you will notice it is much simpler than our first one. I know you don't believe me, but just follow along and you will see this. And then we will be finished with our energy unit for these 2 weeks. Okay, so this is the equation we're going to use, so just try and follow me here. All right. So you'll get a problem that looks something like this, right? It says calculate the heat needed to change 250 grams of liquid water into steam at 100 degrees Celsius. So what I'd like you to try and focus on is what phase change is happening when I say liquid water is turning into steam. That is the one thing you have to pay attention to, is which phase change is happening. You need that because it's going to tell you which heat, either fusion or vaporization, you need to use. So in this instance, water turning to steam is vaporization. Okay, so just hang on for a second. All right, so here's how you solve this now. So we're trying to find the energy it takes for liquid water to turn to steam. So what you need is Q pH. You don't have to write the pH. That's because I'm doing this with you. It means phase change, but you're free to keep writing it. Equals M is mass, which I provided. And then now we need this heat of vaporization. So when you try my practice problems, I will provide these to you, but I wanted to keep this kind of like class time. So how come it's not up here in the problem? That's because I gave it back here on this chart. So here's water, right? Fusion or vaporization, we indicated this is vaporization. So this is the value that you need, the 2260. Again, when you practice these on your own, I will provide these values to you. All right, so let's fill it in now. 250 grams, I gave you how much water you have. The 2260 is the heat of vaporization. I will provide that to you. And then how do you solve this? So all of these problems are just multiplying. And the only thing you have to pay attention to are the units. So if you're trying to solve this with me, it's 250.0 times 2260 in the calculator. So just multiply them together. And again, you're going to get a large value because Q is still heat, which is still energy, so it's large. So the answer is 565,000. Why is it just J? Because if you look up here, the G and the G cancels out. So it's joule. So I hope this makes sense. You are just multiplying mass, how much you have, by the energy it takes, or the heat energy it takes to make that phase change happen. Okay, next one. All right, so we're going to try the previous example, right? We're just going to recalculate this for a different phase. So it's still water. So we're going to have 20 grams of it, but now it's melting, which indicates fusion. Okay, so fusion is back here, right? For water, right here, this is the value. Okay, these are set values. I will provide these to you when you're working on your own. But for now, this is my notes, so I just wanted to utilize them. So here it is. It's 20 grams of ice. That's how much you had. Ice is melting, so we need the heat of fusion, which is a set value. Plug this into your calculator, 20.0 times 334, and you get 6,680 joule. Why is it just joule? Because the grams cancel. Remember, this is fusion because ice was melting. Okay, let's try one more. All right, now it says calculate the heat needed to melt. Okay, 15 grams of an ice cube. And if it's melting, I just provided the temperature to you. It's 0 degrees to give water at 0 degrees. If it's melting, that is solid to liquid, so it's 0 and 0. So if you notice the temperature doesn't change, you don't need to use that. I'm just telling you I can provide that to you, but you don't have to use it. Temperature is out of the equation for these problems. So again, it's M times the heat of fusion. M is our 15-gram ice cube. Heat of fusion, again, it comes from that chart that was in my notes. I will provide this to you. If you multiply this in your calculator, 15 times 334 is 5,010 joules. So the grams cancel. Okay, so it's a little bit easier than the original Q equation. So when you're solving with heats of fusion or heats of vaporization, these will be provided to you. The mass will be provided to you. You just multiply and be sure to keep your units in joules.